Alright guys, so this is just a video. If you're still struggling with factoring, this is a great video to watch for those of you who may need some tips and tricks to help you figure out how to do factoring. By all means, you can skip around, see which ones you need to see, but I'm just going to start with number one and just start grinding through this worksheet. So, number one, where I'm starting is right here at the end. It's negative, okay? My a value is 1. So then when I'm building my parentheses, I know that it's x and x because the a value is 1. Also, I'm going to go plus and minus because of this negative at the end. Now I'm thinking of my factors of 27. We have 1 and 27, 3 and 9, and that's really all we have. We need to make negative 6 in the middle, so I'm looking at 3 and 9, and we can make 6 out of that, and we need it to be negative, so I'm going to make the bigger number negative, so negative 9, positive 3, and then that should be my answer. And then we can double check, right? This is going to be 3x, this is going to be negative 9x, negative 9x plus 3x gives us that negative 6, okay? So always, always, always check your answers with these questions, guys. We box that up because that's our answer. All right, number two. Number two, again, a value of 1. So we're going to go x and x. Positive at the end this time. Positive means that our signs match. What do they match to? They match towards the middle value here, so plus and plus. We have 1 and 6, 3 and 2. We need 7. 1 and 6 can make 7, so if we just plug in 1, plug in 6, that should work just fine. All right, number 3. So this one, we have 3, 9, and 6. It looks like we can pull a greatest common factor out of there. If we divided all of those by 3 and move the 3 to the front, that would give us x squared minus 3x plus 2. Now we have to make sure and see that this can continue to factor. Okay, so then we're going to go 3 still stays on the outside. Now we have our two sets of parentheses. Plus at the end tells us that we're matching. What are we matching to? This time we're matching to negative. So x minus and x minus in both of these things. And then we only have one option for 2, and it's 1 and 2. Double check to make sure this works. So negative x, negative 2x. If we add these two things together, we do in fact get negative 3. So all is good. We box this answer up, and we're in a good spot. Okay, next one, greatest common factor popping up again, right? X is in both of these, so we could pull an x out. We're going to get 2x plus 1, and then that's it. There was only a greatest common factor that was going to come out of this. We can't factor 2x plus 1 any further. It's already just a binomial term. Number 5, so number 5, this is actually one of our special ones. The way you can tell, we have a perfect square here, perfect square here. If we square root the perfect square in the back, you get 5. If you add 5 to itself, you get 10. Okay, that's how you can see if it's going to be a perfect square trinomial. So in this case, our perfect square trinomials, both going to be negative because that middle term is negative. It's x and x, and then 5 and 5. We can always simplify these because they're the exact same term down to x minus 5 squared. Okay. All right, number 6. Number 6, we now have an a value. So whenever we have an a value, we always need to double check to make sure that a greatest common factor can't come out of everything. We have 7, 24, and 20. Unfortunately, 7 is not going to go into 20. Right? So we don't have a greatest common factor. 7, though, is a prime number, so we only have to deal with 7 and 1, which that's a little bit nicer, right? So when we're building these, we have 7x. Sorry, iPad just freaked out. We have 7x, and we have x. Positive at the end, negative in the middle tells us minus and minus, okay? We need negative 24. That's a pretty big number. So we have 1 and 20, 2 and 10, 5 and 4. Okay, so let's see if we can't make negative 24 out of some of these things. It's feeling like 10 and 2 would be too big. What about 4 and 5? If we did 4 and 5, we could do 4 times 7 would give us 28. That's too big, right? Because they're both negative, so we're going to add them together. So what if we did, I actually like 2 and 10, right? If we did 2 times 7, that would give us 14, and then 10 times 1 would give us 10. So this is negative 10x, negative 14x. If we add these two things together, boom, we get negative 24. So it looks like negative 10, negative 2 is what we want to do there. Okay, so then that's our answer. All right, let's take a look at the next one. Number 7, we have 4, 28, and 45. It's looking like no greatest common factor again. You can always check this, right? 4 is divisible by 2 and 4. So is this divisible by 2? Yeah, it is. But is this divisible by 2? It is not. Nor is 45 divisible by 4. So we can't pull a greatest common factor out of here. Instead, we have to just start going to town on the factoring. So we have 1 and 4, 2 and 2. 45 has a couple factors, 1 and 45. Okay, 15 also comes out of 45. What is that? What is 3 and 15? Yep, and then 5 and 9 are going to be our factors here. We have a negative 28 in the middle, positive at the end. Well, that is a little bit helpful to us because that tells us negative and negative, which is nice. Okay, we need negative 28. How am I leaning towards negative 28? Negative 28 is a pretty big number, okay? So if I'm looking at 2 and 2, I'm probably going to look at, really any of these could work. Okay, so we might just have to start going at this one. I'm feeling like 1 and 4 might be too big, right? Because 4 times these terms already makes us bigger than 28, which we can't have. So I'm leaning towards 2 and 2. So let's go 2x and 2x here. And then I'll just start with the bottom terms, and we'll move up from there just because smaller numbers are easier to multiply than bigger ones. So if we did that first, we would put 5 and 9. It wouldn't matter because we're multiplying both by 2. So if we did this, we'd get negative 10x. If we did this, we would get negative 18x. And would you look at that? Negative 10, negative 18, negative 28. Okay? So just by some deductive reasoning, right, we actually figured out what our answer was with just our first guess. Okay? So, number 8. Let's take a look at number 8. Number 8, do we have a greatest common factor? Nope, because can't divide anything by 19. So we're going to go 3x and x. Again, plus in the back, minus in the middle. Tells us minus and minus. 1 and 28, 2 and 14. What is that? 3, nope, 4 and 7. So those are our options. Negative 19 is pretty big. We have minus and minus. I'm liking maybe, I don't know, 4 and 7, 2 and 14. 2 and 14 might be a little bit too big because that's going to take us to 20 if we did 2 times 3. So that would be 6, and then 14 would be 20. So looks like we have to work with 4 and 7. We just got to figure out where they go. Looks like 4 times 3 would give us 12, right? So that's negative 12, negative 7. And then those two added together would give us negative 19. So then it looks like we filled it in good right there. All right. Last one for this top section here. We have number 9. So we have 8, 42, 54. Okay, it definitely looks like 2 comes out of all of those things. So let's just divide them all by 2 to start. So we pull the 2 out. Greatest common factor gives us 4x squared plus 21x plus, what is that, 27. Does anything else come out of here? 3 and 3, but 3 doesn't come out of 4. So it looks like that 2 is the biggest number we could pull out of here. So we have to work from here. So we have 1 and 4, 2 and 2. 27, we have 1 and 27, 3 and 9. And that's it for 27. Okay, so now we need to make positive 21 in the middle. So we have 2. We're positive at the end, so positive, positive, because of the positive in the middle. So then let's try to figure this one out. Positive 21 is pretty big, okay? So maybe we'll start with x and 4x. And we'll just see where it goes from there. Just because 21 is so big, that's why I'm thinking x and 4x. But we are adding them together, so maybe it could be 2x and 2x. Let's just go with x and 4x and just start guessing. 27, definitely too big, right? 27 already, if we added it to anything, is bigger than 21. So that one doesn't work right away. So let's go to 3 and 9. So we're looking at 3 and 9. If we did 3 here and 9 here, that's too much. That would give us 36. So let's go 3 here is 12 plus 9. That actually looks like it works. So 12x, 9x, so 9x and 12x. Does that give us 21? Yeah, it does. Sweet. So it looks like we needed x plus 3 and 4x plus 9. Bada bing, bada boom. And we finished the first little section. All right, guys, moving on to the next page. Okay. The next page says solve the following quadratic. So this time we need to factor and then get the x values. So if we're working here, we have 10. For number 10, it looks like we're back to a values of 1, which is awesome. So we can move to x and x. Plus at the end tells us that it's matching to negative, so minus minus. And then 2 and 4, 1 and 8. 2 and 4 can make 6. So those would be our factors, x minus 2, x minus 4. And then when we solve this, we just set them equal to 0. So we would get add 2 to both sides on the left. We would get x equals 2. Add 4 to both sides on the right, and we would get x is equal to 4. All right, number 11. Number 11, we don't have a greatest common factor that comes out of all of those, unfortunately, so we have to just work with what we have. So I'm thinking 1 and 4, 2 and 2. 1 and 5 is our only options for the back. Unfortunately, it is minus, so it's going to be a plus and a minus in here. And then we just got to figure out where it's going to go from here. I'm seeing 8 in the middle. Because we have to do some subtracting, I like 2x and 2x. Okay, I like 2x and 2x because knowing that I have 5, I can make 10. And if we have to subtract from 10, that can probably get us close to 8. So we need a positive 10. So I'm going to make positive 5. That would give us our positive 10x, right? And then we have to put 1 here. 1 gives us negative 2x. Negative 2x, positive 10, positive 8. Okay, so our factors are good. From here, we use our factors to solve the question. So 2x plus 5 is equal to 0. 2x minus 1 is equal to 0. So that's 2x equals negative 5. So that's going to be x is equal to negative 5 halves. On the other side, we have 2x is equal to 1. So that's going to be x is equal to 1 half. And these would be our two solutions. All right. Number 12. So, number 12, big numbers all around here. Checking if a greatest common factor can come out. We only have 9. We only have 9 and 3 that we can divide 9 by. So then we're really just checking, can 62 be divided by 9? Nope. Can 62 be divided by 3? Again, nope. So nope for both of those things. So no greatest common factor here. So we just have to work with what we got. Okay. Whew, this is a hard one. So positive, negative. So we have negative, negative. Okay, that's nice. Now we got to think of 48. So we have 1, 48, 2, 24. What is 3? 48 and 16. I think 3 and 16. We have 4 and 12. Holy smokes, this has a lot of factors. What else is 48? 6 and 8. Okay, so lots of options there. 9 has 1 and 9, 3 and 3. So negative 62, that's pretty big. So I'm kind of leaning towards 1 and 9. So let's go 9x and then x. Okay, the reason is because 9 times something is going to get us a pretty big number. So I kind of like that. So now we just need to make a big number, but not too big that we're just going overboard with our numbers here. So 62 is pretty large though. So let's think. 9 times 12 would be too big. What's 9 times 8? That's 72, so that's too big. But 9 times 6 is 54. 54 and 8. Does that work? So 9 times 6, so that's negative. And then 8, so we're going to go, boom, that gives us negative 54x. That's negative 8x. 8 and 54 makes 62. So that looks like it works. Okay, so 9x, or 9x minus 8, and then x minus 6. So if we're solving this, 9x minus 8 is equal to 0, x minus 6 is equal to 0. Solve this would be 9x equals 8, so x is equal to 8/9. On the other side, we have x is equal to 6, and then these would be our two solutions. All right, continuing on. Here we have a greatest common factor. That's awesome. So let's pull it out. 6 comes out of both of those, x comes out of both of those, so that leaves us with x plus 10 is equal to 0. So 6x times x plus 10 is equal to 0. One thing that you can do here, this is a factor and this is a factor. So we have to treat both of them and set them both equal to 0. So if 6x is equal to 0, x plus 10 is equal to 0, both of those things would work. So we divide by 6 here, we get x is equal to 0. On the other side, we subtract 10, we get x is equal to negative 10. Boom, boom, two answers. All right, 14. Ooh, 14 is a difference of squares. That's kind of nice. So we go x, square root both of these, we get x and 8. So x plus 8, x minus 8. So then our two solutions are x equals negative 8 and x equals positive 8. Difference of squares are awesome, so quick. 15, we have to set this thing equal to 0. When I'm factoring, I like my x squared to stay positive, so I'm going to subtract 49 to the other side. 25x squared minus 49 is equal to 0. Difference of squares again, perfect square in the front, so we can square root it, 5x. Perfect square in the back, so we can square root that as well, 7. So that's 5x plus 7, 5x minus 7, okay? So another way to write these kind of solutions, guys, is to say x is equal to plus or minus, and then it's going to be 7/5 when we solve both of those, because this is accounting for the positive 7/5, and then the other answer, the other answer, the minus portion, is counting for negative 7/5. Okay. All right, last row. Again, we have to set it equal to 0. So 25x squared minus 45x minus 10 is equal to 0. Okay, we can pull a greatest common factor out of all of these things. 5 comes out of everything. That's 5x squared minus 9x minus 2 is equal to 0. In this case, we can divide the 5 off so we don't have to worry about it anymore. Because there's no x with it, if we divide 5, it'll just get rid of it. So 5x squared minus 9x minus 2 is equal to 0. Now we can factor. We have 1 and 5, 1 and 2. So that's 5x and x. Okay, we need a plus and a minus. We need negative 9 in the middle. I'm thinking I'm thinking negative 2 here would give us negative 10. Positive 1 here gives us negative 9. So x is equal to negative 1/5, and x is equal to positive 2. All right, so last two here, so that's 9x squared minus 12x minus 32. Again, I like to keep the x squared portion positive. Makes factoring way easier. What comes out of all these things? Anything? Does 3 come out of 32? I don't think so. We might just have to work with what we got right here. So we have 1 and 9, 3 and 3, 1, 32, 2, 16, 3, 4, and 8. Okay, so let's try to build some factors here. Gosh, where should we start this one? We have negative 12 in the middle, so maybe we want our values closer. So I'm thinking 3x and 3x. And then negative 32 in the back. So negative 12 in the middle. 3 and 8 is 24. Ooh, 24 is nice. So let's go, we want negative 24, so let's go negative 8. So if we put 4 here, that would give us 12x. This would give us negative 24x, which does make negative 12. Awesome. So then x would be negative 4/3, and x would be 8/3 once we solve both of those factors for 0, okay? All right, last one here. So make this positive, makes it easier. So we're going to add it to the other side. So we'll have 5x squared plus 13x, okay? And then this is a positive 8, so plus 8 is equal to 0. 1 and 5 in the front, 1 and 8 in the back, 2 and 4. Okay, so we have 1x and 5x. It has to be plus and plus. We need 13 in the middle. So 2 and 4 would make 14. 8 and 5 would make 13. Okay, so that's 5x, 8x. So that makes 13 when we add those two things together, so we're good. So x is equal to -1, and x is also equal to -8/5. Boom.